Hi everyone, my name is Camilo Andres Gonzalez Ayala and this is a short presentation for Science Forum 2021 water lessons about the application of natural language processing in water resources using as a case study La Paz Choqueyapu River Basin located in Bolivia. In recent years, technology has advanced a lot and we can obtain information on any subject on the internet. For example, by going to the website of a newspaper, we can obtain news about problems, projects, and propose solutions in a river, a lake, or a community. On the other hand, social networks, such as Twitter, have become an open source of communications in which anyone can give their opinion of any topic, some in a more technical way than others that can use local terms or emojis to describe the status of something. However, this could become useful information for those who can store it, analyze it, and take advantage of it. Understanding that we are in an era where personal communications to collect and integrate information for planning processes in the water resources management are difficult due to the COVID-19 situation, it is necessary to look for another alternative source of information that may involve stakeholders. Then, as a hypothesis, the use of natural language processing in unexplored digital information sources, such as public media and social media, could help to complement a watershed characterization and to understand their problems as well as possible. Then, what is natural language processing? It is a branch of computer science, more specific, a branch of artificial intelligence. It combines computational linguistics that are rule-based modeling of human language with statistical machine learning and deep learning models. Together, these techniques enable computers to process human language in the form of text or voice data and to understand its full meaning according to the speaker or writer's intents and sentiments. Some real-world applications are spam detection, machine translation, text summarization, and public and social media sentiment analysis. The case study corresponds to La Paz Choqueyapu River Basin located in the South American country of Bolivia. This one is one of the 14 basins under the Bolivia National Watershed Plan. It is also a subbasin of the Amazon Basin with a surface area of 489 square kilometers. Some principal municipalities are La Paz, El Alto, Achocalla, and Mecapaca. The hydrologic year starts in October with a rainy season between October and March, a dry period between May and August, and the transition months are April and September. The application of natural language processing for this case study consisted of identifying keywords such as water bodies and systems like rivers, lakes, reservoirs, wastewater treatment plants, among others, also names of municipalities that are part of the basin, hydroclimatological processes like rains, floods, drought, and perform a search for each keyword on each newspaper and Twitter using a technique called web scraping, which allows to extract text from a web page and store it in a database. Then, the stored information is divided into two sets. Trained data, which is the information used in such a way that the model learns to associate a text with a corresponding output. Can be a value, a numeric value, or a classification, it's up to you, according to the information found. The information must be pre-processed, that is, converted to a format that can be understood by a machine. Some processes are tokenization, stop-word removal, named entity recognition, and word embedding in which each unique word of each text is converted to a numeric value. Once the information is pre-processed, it is used to build a text classification model using machine learning or deep learning classification algorithms. The result of this model is a number between 0 and 1, a classification as negative or positive, that describes the sentiment found in the text according to the emotions represented by each word on it. This is called sentiment analysis. Once the model is built, the test set is used to evaluate the performance of the model. The test information is again pre-processed, enters in the classification model, a sentiment value between 0 and 1 is obtained, and the results are evaluated using metrics such as precision, accuracy, that could determine the functionality of the model. The frequency of information can also be related to keywords. In this case, there is evidence for the keyword precipitation, where a high number of articles present this word in rainy seasons. On the other hand, a low quantity of articles in dry seasons. Another application of this process is a word cloud in order to check the words that are repeated most frequently in a text or a time period. From the word cloud, it can be inferred that for the November 2016 period, the most frequent topic was water shortages due to the absence of rainfall or drought. which led to a water crisis and emergency causing water rationing in the municipalities of La Paz and El Alto. By grouping the text as positive or negative, the most frequent topics or words can be determined at a specific level, such as in a community like El Alto, where the words most frequently found in a negative classified text are potable water, emergency, rationing, risks, and sanitation. In a positive classification, these same words were found less frequently, in addition to the word investment, which allows us to understand that action and projects are being taken to solve these problems. In the community of Mecapaca, there are words related to risks, crops, landslides, and overflows in the text of negative classification, while in the text of positive classification, words related to treatment plants, drinking water, garbage, and sanitary landfill allows to understand that there is a pollution problem in the sector. Another scale of analysis can be a river or a water body. For this case, the Choqueyapu River presents words related to landslides, risks, leachates, and garbage in both classifications. In general, for water bodies, information about the river or water body health is obtained. Some of the conclusions are, from the application of natural language processing, adjectives, verbs, places, keywords that describe the processes that occur in a watershed can be identified. These words are presented in a non-technical and direct language, which is related to the concept of citizen science and interdisciplinary participation, which can be useful for the planning processes for the water authorities. Also, by grouping the text as positive or negative, the most frequent topics or words can be determined at watershed level or at a specific level such as a community or a river. Finally, future work may consist of developing a platform that classifies the text of social and public media as positive or negative and that extracts keywords in real time in order to perform an effective management and operation of different processes in the watershed. With this, I conclude my presentation. I hope you enjoyed it and see you in the Q&A session.